The method of superposition is not only limited to unit hydrographs, but for direct runoff hydrographs with different cases during the course of the storm. Learn how the method is used here in hydrology. From the previous videos, when we derive a unit hydrograph, note that the examples such as the one presented contain a direct runoff hydrograph with 2 hours intervals. Then we have converted this DRH into a unit hydrograph of the same interval, a 2-hour unit hydrograph. So to cut it short, a 2-hour DRH is provided and converted into a 2-hour unit hydrograph, or a 3-hour DRH was converted into a 3-hour UH. But how if what we have is a 3-hour DRH and what we needed is a 2-hour unit hydrograph? Are we just going to work on ratio and proportion? The height or discharge can be transformed by merely division or multiplication, but with change of duration, specific methods are employed, one of which is the S-curve method. Besides the time and discharge usually provided, the method requires computing the coordinates of an S-curve. This is another additional column to be completed to arrive at the transformed unit hydrograph. This approach is a bit more technical, but this does not have any limitations. Thus, it is considered as the general procedure. Another approach is simpler than the general procedure. It is the method of superposition. The procedure of this method is simple, however, it has a limitation. The method of superposition only applies when the required unit hydrograph is a multiple of the provided UH. For example, superposition can be used if the problem provides a 3-hour UH and the required is a 12-hour unit hydrograph. 12 is a multiple of 3. The second example involves a small watershed where the 1 centimeter unit hydrograph has been established, as shown. There was a recent storm over the area and it produced 2 centimeters of effective rainfall in the first hour, and another 1 centimeter of effective rainfall in the second hour. We are to determine the resulting direct runoff hydrograph using method of superposition. There are 2 events during the storm. At the first hour, the storm produced 2 centimeters of effective rainfall. Since the duration or time interval did not vary, we can simply multiply the runoff by 2, giving 0 for T0, 10 for T1, 20 for T2, 12 for T3, 4 for T4, then 0 for T5. The second hour rainfall maintained 1 centimeter of effective rainfall, starting on the second hour. A lag is needed where the unit hydrograph will then start at the second hour. The total direct runoff hydrograph is determined by taking the summation of the 2 columns, starting at T0 with 0. Then T1 has 10 plus 0, which is still 10. T2 has 20 plus 5, or 25, followed by 12 plus 10 at T3. Then 4 plus 6, making 10 at T4, with 0 plus 2, or 2 at T5. This is the total runoff. Now you might be thinking of creating a unit hydrograph from this column, by dividing the total runoff by the depth, which might be 2 centimeters from the first hour, then 1 centimeter from the second hour, making 3 centimeters. Although that procedure sounds feasible, take note that for a unit hydrograph to be computed, one assumption is that the rainfall should be constant during the whole duration. Thus, fluctuations on the rainfall violate the assumption. This is for you to check if you understood the procedure. A watershed has a 1 centimeter unit hydrograph in record. A storm in the area was observed for 3 hours, where the first hour was 1 centimeter, the second was 2 centimeters, and the third hour was again 1 centimeter. You are to determine the direct runoff hydrograph using the method of superposition. Again, a unit hydrograph is not simply computed from the DRH. The solution will include 3 columns for each hour, and don't forget the time lag for each event. If everything is properly computed, the peak discharge is 26 cumecs and it is at T 3 hours.